So we know what Java is all about now. We have a little simple, we made some simple programs last time. We know how to compile Java programs and run them inside of the Java virtual machine. It's beautiful. There's some naming conventions that we understand now. I think a good example would be a counter class now, just to kind of see the differences, because I loved that example in C++. We're going to love it again in Java. Let's make a counter class with a constructor, a getCount method, an inc method, and a reset method. Okay, so we'll do all those things. And the idea is like the constructor, you make a counter C object. Just as usual, it should have like a count member variable, count. Starts out at 0 with the constructor, right? And then you should be able to inc it, right? It'd be like c.inc. All that syntax exists and is the same in Java. Like make it 1, make it as many as you need it to be, 1, 2, 3, whatever. Let's also have this reset method, like reset the count back to 0 if you give nothing. Let's be like c.reset. If you call it like that without any arguments, it'll just like reset the count to 0. And then if you give it arguments, though, let's make a reset also work like this. Like if you give it a number, then it will reset the count to exactly whatever that number was. I think that'll be a good example. Okay, so let's do that, and I'll walk you through it. So if I want to make a counter class, I better make a Java program called counter.cpp, with a capital C. So let's do that. Sorry, not counter.cpp, counter.java, excuse me. It must be called that if I want to make a class called counter. And it's going to be public class counter where it lives, right? And this is where I'm going to put the counter class. I'm also going to put the main function here. So let's do the main function right now, and you'll kind of see like it's separate. This is a public static method, right? Static void main string array args. Now let's pretend I've made the counter class. All right, let's use it a little bit. Let's be like, all right, counter C. You can't do a semicolon here. You can't make stack objects in Java. Everything goes on the heap. You have to say new all day long. But that's fine because it calls delete for you. Counter C equals new counter. That's how you must say it in Java. You got to make a brand new counter, and you're not getting it as a pointer. There's no such thing as a pointer, just like everything, because it's all made on the heap. Like Java's fine with it. They call it references, which is very confusing coming from C++, I know. So by default, the counter's count should be 0. So if we printed that with our system.out.println c.getCount, this should print 0, right, by default. That's the first thing that we should see. And then if I inc it a few times, be like c.inc, that syntax will exist as usual. Then if I print the count now, it better be 3, right? That's what I should see. And then let's just like pretend I have all these things, see what's going to happen. Let's be like, okay, let's call our reset method. It'd be like c.reset. That should make it back to 0, and then I can inc it a couple times. Now it should print 2 because it's 0. Inked twice makes 2, so it should hold 2 now. And then we're also going to have this reset that changes it. So it'll be like c.reset to a certain value, like 42, and you can inc it after that. So now it should hold like 45. Boop. So that's what we should see. That's the output that we should see. And so let's get that working. So, all right, let's give these methods. Let's make them exist now. So I'll put them above. So this is the counter class, by the way. This is the main function. It's a static method, so it's acting like a function. It's not really part of the class, all right? It's like part of the class itself rather than objects of the class. To make actual normal methods, you're just not going to say static, okay? So read your book about this. I promise it's in there. But let's start doing stuff. You just start giving things, okay? So first of all, like I kind of said last time, you do not, let's see, let me do this in order, sorry. I think I said this already. When you use new, you get back what's called a reference, and you can just immediately say dot on it. Like this was on the heap, but I'm saying dot get count. So that's one thing. You're just allowed to do that in Java. And then the next thing is there's no declarations, right? There is no such thing as function / method declarations. So you just start giving stuff in any order. Java will find it. It's happy. Also, you also can't say public colon, like everything below this is public, or like private colon or anything else. So that means you have to, like I'm doing here for main and for the class itself, you got to put it next to it, okay? You got to say, so you have to put public / private next to everything. Which is nice because at a glance you can see exactly what it is, but it's kind of extra wordy. Right? So, okay. Every counter object needs a count member variable, so I need to put that in the class. Right? So every count member variable needs that field. We need one field called count, and it's going to be private, right? Because it's a member variable. We should be good programmers and make it private. And so it's going to be private int count, semicolon. There is your member variable. Okay? And now let's do the constructor. Will be like, well, it's a public method. Every constructor is always public, right? Count, it's called counter, returns itself, essentially. There's no return type, just like in C++. And what should the counter do? It should set that initial count to 0, right? For the default constructor. Set count to 0. There's no initializer list in Java. You just got to do it in the body. My count is 0. So there's your constructor. Nice. What else do I want to say? Yeah, what other things do I need to make now? I need to make the inc method, right? All these things that I'm trying to use. Inc and get count, all those fun things. Let's do get count first. So get count is a public method that returns an int, right? Return count. There. You cannot mark a method as const in Java. We can't mark a method, because get count should be const, right? Method as const. Let me just say very easily in Java. There's a way that I don't fully understand to enforce that, but it's not like baked into the language or easy. So that's a thing that you have to just forget about. So that's get count, and then inc is public void, right? Public, it's a void method. Inc takes our count and does count plus plus. That's fine. And then I want to do what was next? Reset, right? Reset without anything, and then reset with something. What do I want to say here? You could have done this in one function in Java. So like here's this public void reset without anything. Just like should set the count to 0, right? In C++, you could have done the parameterized one as well with the same thing, with default parameters. Have you seen those in your book? I forget if I've told you about that. In C++, you can do this, like, all right, int new count, and then it could like default to 0 or something. Have you seen that syntax before? Like that's a thing you can do in C++, but you cannot do in Java. So if you want to reset without anything, you just got to give it separate, okay? If you want to reset with something, you got to do it as a second version with the same name. All right, so Java doesn't have default parameters, so you have to make two separate reset methods, one that takes nothing and one that takes something. Could have done it in one with C++ default parameters. So all right, let's have a reset that takes something, int new count. And I'll just set the count to that new one. All right, so I'm forced to have two separate methods instead of just using one. Like I could have done it like that, and then I didn't need this one in C++. But that does not exist in Java. That should more or less do it, I think. Let's see if it works. So all these mostly make sense, I hope. So we'll Java C it. I got this file right. Java C counter.java. It creates. Oh no, I messed something up. Good. We get to see Java compiler errors. They're much cleaner than C++ compiler errors. I forgot semicolons. How dare I? I've got Python on the brain, probably. Let's see. Because that's where we're going next. So I need these semicolons, of course. Shame on me. And then we get our nice counter.class that we can run with Java. Java counter. Bam. And so I do see my 032 45. Beautiful. Any questions about this? Does that make enough sense? It's very similar. Very, very similar. All right, the last thing that I want to do is let's do an operator, right? Let's be able to add two counters, one counter to another. Sadly, in Java, you cannot do this. You can't be like C plus C2. You cannot overload the plus operator on non-basic types, which is really, really sad. I love that fact of C++. In Java, you have to make it wordy. You have to turn it into a method, first of all, and it's got to be like with words. You got to be like c.add. There's no such thing as overloading the plus operator, so the best you can do is call it like the .add method, which is unfortunate, but that's what we got to work with. So let's make that. So let's make a second counter so I can add it to my C, my original counter C. Let's make a counter C2. equals new counter. Everything's on the heap. Garbage collected for us though, and we'll make C2 hold, let's say 3. So let's see, C holds 45 as its count, and C2 is going to hold 3 now as its count. And let's make counter C3 equal to, hey C, go add yourself to C2, and then the count inside should hold like 48, right? If we print C3's get count, that's kind of how I want to use this. So C3's get count should hold 48. Oops. There. So that's what I should see there once I implement this .add method. So it's taken somebody, and let's bump up here. So it is what? It's a public method. It's called add. It takes some other counter called other. You can't, there's no such thing as constant references or anything. It's just like you're taking it. It's fine. And then it's going to return another counter. All right? So that's the type of that. And like we're coming up here when somebody says c.add c2. Okay? That's what's happening. We're jumping up here, and our job is to return a third counter. We've got ourselves and the other counter. Got to make a third counter with that count. Okay? So what's the count that should be inside this new counter that I'm going to return? It's like the summed count is my own count plus others count. Okay? So that's what's going inside the new counter. So I'll make a new counter called counter res, new counter. And then I am inside the class, so I could say res.count equals some count. Or I could use my reset method. I could do res.reset to the sum count. Either one works. And then I'll return res as my result. That's my new counter with the updated count, and then this should work. Java C, Java to run it again, and there's my 48 at the end there. So I'm jumping up to here when I call the .add. Okay, so that's the last thing that I want to show you for this program, I think. Yeah. Sadly, you can't do the plus. It only works for numbers and strings, like types that are baked into the language. Yeah, so any questions about this program? So I got more. Yes. Integers, any basic type like an integer, a double, bool, stuff, boolean, stuff like that. Those are normal stack variables, but everything else is on the heap. Every object on the heap. Yeah. Good question. All right, let's go now to this nice list. So here's just a list of differences. I've already said a lot of these between Java and C++. This is thanks to Bill Kearney, the other computer science professor here. So I stole this list from him. So first thing, it is Java is what's called, or it's compiling to an intermediate language. Okay, it's not compiling to machine code. It's compiling to an intermediate language, and that's why these .class files, you can like compile it on Linux and you can go run it on a Windows computer or run it on Mac OS. Like, that's what Java likes. They do it that way. And you need Java installed to run the final thing, though, that class file. So that's the difference. It's compiled to an intermediate language called Java bytecode. It's not machine code. It's not yet runnable. That's one thing. You can't have, there's no such thing as const parameters or const methods, but you can have const variables, as usual. They don't call them const, though. They call them public static final. So public static to make it part of the class, so it's not hooked into every object. Just need it once. And then final to mean like that's the last thing it could ever hold. It never can change. There's that. Instead of char, they say byte. Just like we saw, there's no pointers or stars anywhere. There's only references, and you can just immediately use the dot. Like it understands everything's on the heap anyway in Java, so like makes it nice for you. It will clean up after you, which is pretty cool. We don't get operator overloading, which is very sad. So we have to do .add instead of the plus. I will show you this in just a second, but instead of like using number sign include and like namespaces, there's the way to include a library is called importing, and their name for library is called a package in Java. There's that. One cool thing that you might have to wait until CSCI 41 to fully understand is that every class in Java comes from the object class. It's deriving from a base class called object. So this is just like, you know, that ifstream example I showed you in class once upon a time. ifstream inherits from istream, and it gets all the things out of that. Like that's where the read into me operator comes from in C++. Like there was an inheritance going on there. Just by default, every class you make in Java inherits from a class called object that gives you some cool things for free, like a toString method, for example, you get for free. You usually want to change it, but at least you know it exists. Like, everybody's inheriting from this, and I think that's all that I want to say about that. Read the chapter of your textbook about inheritance to fully understand that. I would say that the compiler is significantly better than the C++ compiler because the language is slightly simpler, and then it will give you nice hints because of that. And also, if you do your comments right in the cool way, there's a way to automatically generate documentation for your Java programs, which you can't really do very easily in C++. So like this page that I took you to last time, this entire website is actually automatically generated from the source code of the Java library. It's amazing. Like, all these things automatically generated for you just by writing comments inside of your code. So I love that. What else? So yeah, you don't have to ever say delete, and that's why we're not teaching you Java here, because you'd get very bad with your memory management. I'm teaching you that you have to clean up after yourself. Now you can use it. All right, now you've progressed. And then just the standard library in general, like, it's insanely good. It's so much better than the C++ standard library. You got so many more things, which is great. And I'll show you one of those cool things in just a second. So yeah, I think that's all that I wanted to say there. The final Java example that I want to give today is an example of how the library is amazing, first of all. And then it's going to be finally an example of me making a brand new window, a program that actually displays a window on the screen that you can click stuff. That we have not yet done. That is not really easy in C++. It's not baked into the language or the libraries. So there's a way to do this in C++, but it's much, much harder. So we're going to use the swing library in Java. We're going to import the package called javax.swing, and that's going to give us access to a bunch of things that start with the letter J that will allow us to make little buttons that we can click and little windows that we can display on the screen. It's going to be great. Okay, so what we're going to do is we're going to make a graphical user interface for our counter class. We pronounce it as GUI for short. That's what people say. We're going to make a GUI for our counter class. It stands for graphical user interface. And what we're going to do is the following. Let me just show it to you. What's going to happen? I've already made the file. Counter-GUI.java is what it is. And here it is. It's going to hook into our counter class. It's just going to get that for free. And it's going to use it. Let me make sure I'm done with this here. What else do I want to say? Am I on the right page? No. Sorry, I accidentally closed a page here. Okay, I think that's what I wanted to do. So yeah, I guess I can show this to you. Dun, dun, dun. Here's counter-GUI.java. A few things that we'll talk about later. It's going to import the packages, first of all. Import everything from the swing, javax.swing package. That's what the star means. Give me everything. And then for the clicking of the buttons, that comes from the idea of an event. And so I need the event package stuff as well. We'll get to that. But public class counter GUI, blah, 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 a bunch of stuff that starts with J. I'll talk about all of this. But let me just show you it running. Java C counter GUI.java. See how it's going to use our counter class by default. And I'll say Java counter GUI, run that main function, this one here. Bam! So here's the program we are going to make. Oh, did it open? There it is. Look at it. Nice little window. And it hooks into our counter and has a little display and two buttons. Increments the count. Click it. And resets it back to 0. So this is going to, like our counter, we're going to have a counter object as the database, the state on the back end. And just every time you click it, it's going to call the inc method. Every time you click this, it's going to call the reset method. And it's going to update the display. That's what we're going to make. Okay? That's pretty cool. You get that from the language for free, the libraries. So yeah, here's how we're going to do that. So we are going to use our underlying counter because we have a counter class that has every piece of data we could ever possibly need for that program, right? It has the counter's count. It has the ability to call inc and reset. Like, that's what we're going to use under the hood to keep track of all the data for our GUI. And we don't actually have to say import counter like all these other things. It's just because it's in the same folder, like we get it. So that's pretty nice. It's just Java sees that. And then I'm going to make, just for fun, a global variable. Here's an example of a global variable. That's going to be our database. That's going to be our counter. It's private static, all right? Static means it's part of the class, so I can use it here in the main function. static method. Okay, so here's a counter. It's like set to null by default, I think, and just the first line in main is like, well, give me a counter with an initial count. That's my database. Okay, that's going to be that. And then I need to make a bunch of things that start with J's and just like use the library. So here's kind of the goal. All right, and I'll show you all these cool things. But the button, for example, is called JButton. There it is. And I'll show you how to use these in just a second. But the idea is we're going to have our counter be our database. Like every counter has a count inside of it. Starts at 0 with the constructor. And like that's going to be part of our window, right? So we have all these bad boys. We're going to have the display for our counter's count. We're going to have our ink button. We're going to have our reset button. Okay? And the types of these pieces, the display of this text is called a JText field. So we're going to make one of those objects and hook it into our window. Called a JText field. And then these two are called JButtons. So we're going to make two JButton objects and add them to our window. JButton. And then you make a bunch of these things. They're called components. These are the pre-implemented components of the Swing library, Swing package. And if you want them to be arranged horizontally in line, you put them into what's called a JPanel. So this is going to be part of something called a JPanel. So we'll make a variable called panel to hold them. And then if you want to put all these on a window, the window is called a JFrame. So JFrame is the outer thing. That's your actual window with like a name. And you put the panel in the frame. So like this is how it's going to look eventually. The panel goes inside the frame. So I'll make a JFrame object called frame or something. And that's what we're going to do. All right, so let me try to walk you through this code. I'm going to go fast. You can read it if you like. I can help you with it during office hours, but I'm not testing you on it. So it's just, this is all extra. So, okay, so we got to make the window. Here is JFrame, frame equals new JFrame, and the constructor of JFrames, you can look into all of this. The constructor, one of the constructors for a JFrame, you can give a string that is the title of the window. That's what we're making here. Hopefully I closed it, right? So here's the title of the one. It's very small. It's called counter GUI, though. That's what I gave in the constructor. That's just how the library works. So there's that. And then for some weird reason, by default, when you click the X in Java programs and Swing library programs, it doesn't actually close the program. It doesn't actually exit the program. So we have to tell it like, hey, frame, hey, window, when somebody clicks the X, like you should exit the program, please. I want you to do that for me. So like that's just what you have to say there. And yeah, we want to put a bunch of things in our frame. So we got to organize them in some way. We're going to organize them using a JPanel. All right, so here I am making the JPanel. All right, there's that, just default constructor. And then, yeah, then I need to make each piece. So I make this thing that displays the count is called a JText field. It's a field that holds text. Makes sense, right? So the JText field constructor takes the width of the fields. Like I want this to be able to hold at least 3 characters visibly. So I say 3, so you can count up to 100 or 999 at least. And then this text field, I don't actually want the user to be able to type inside of it. I only want it to be programmatically changed. So I'll say set editable false. So I'm making sure that nobody can change it. This is just the library, how the library works. Don't let the user type up in there. We're going to change it programmatically. And then the first thing that it should ever hold is like when it starts, the counter, right? The counter is default constructed to hold a count of 0. Like it should always reference the counter's count right now. And at the start, the counter's count should be 0. So there's a .setText method of the text field object. And you can set it to a string. Set it to a string. So get the counter's count, whatever, it's 0 right now. Make it a string. This is the integer class's toString. It's probably a static method. And that's going to make the string 0. You're going to set the text to that. That's the very first thing it does. Okay, so that's the value in our counter. And then I stole this. There's a set font size function that I made as well, just to make sure that the font size is huge, because by default it's smaller than that. So here I am setting the font size to be big, and I just stole this this function from the internet. Okay, so that's that, making the font size huge. And then I'm doing the same stuff for the buttons. So every button is called JButton. Here is the ink button, and new, and you give as the constructor argument the string that you want the button's name to be. So there it is, and I'll put that there. Make its font size huge. And then you have to hook into whenever the button gets clicked, right? Whenever you click it, you want to do something, so you got to give code that you want to run. So it's called an action, all right, or an event that happens whenever a J button is clicked. So we're going to say inc, that's the button's name. We're going to add what's called an action listener. These are just words that the library people came up with. Don't worry about it. We're going to add an action listener in this weird way. You're going to give code essentially in line for what should happen. Like we're making a class on the fly with this method. It's like, really, these are the 2 lines that get run when the button gets clicked. That's all I want you to know right now. It's like, all right, what do? We're going to use our hook into our database, like make sure that the counter, we're going to call inc on the counter. It's like make the count before, and then actually display the updated count. Right? So that's the second, the 2-step process. Actually increment the database, which is just in memory, and then change the text field to correspond again. So set the text to be the string version of the counter's count. That's the secret. That's what happens every time you click the increment button. And a very similar thing is going to happen with the reset button. Make the button called reset, make its font size huge, and here are the 2 lines I want to run whenever somebody clicks the reset button. Actually reset the counter object itself, which is just in memory, and then update the text field to display that updated count. So like go into the get count, set the text field to the string version of that. Okay, so that's the goal. It's like you click it around, like it's messing with. You click inc, for example, it's going to mess with the counter's count, make it 1, and then we're going to also update the panels. The text frames string inside of it. And then you click reset. It's going to update the counter. That's our database, and it's going to refresh the window essentially. Okay, that's what happens. That's the code that gets run. And that's most of it. Like I've made all these things separately. I have to give them to the panel in the order that I want them to be displayed horizontally. So I give the text field first, then the inc, then the reset. I add them to the panel in this way with the panel's add method. And then I tell the window itself. The window is the frame, right? I add the panel to the frame. I hook that into the window itself. It wasn't in there yet. Now it is. And then this .pack, all that means is by default, can I get this to work? Let's see. Can I do it this way? It might take... There it goes. Cool. So by default, in Java land... Come on. You just let me do it. Let me do it again. This is Windows for you. So by default, I think the panel's size is like 1 pixel or something. The frame size is 1 pixel. Either that or some weird default value. All .pack does is like, hey... I put everything in the window. Hey, frame, I put everything inside of you that I ever want to put inside of you. So, like, resize yourself to just perfectly hold those things. That's all that's saying. And then, by default, the frame is invisible while you're putting stuff in it. And then we tell it to become visible at the very end there. So, yeah, and now it works. And it's happy. And that is the entire program. Yeah. So, I think that's all I wanted to show you there. It's advanced stuff. It's just like you got to learn the library to understand it. But you can see the power of Java with it, I think. Okay, so I think that is all I wanted to show you there. Does that make enough sense for now? That's my cool example for Java. All right, so now I want to switch gears and talk about Python. Yay, I'm excited to teach you this language as well. Java is on the, not as many people are using Java these days, is what I'm trying to say. So if you go and you transfer to a school that did not learn C++ first, 99% chance they taught Python first instead. Okay, so this is the more common, this is the other common starter language. Okay, so it's good to learn it. Very useful to know Python. Just that same website exists as well. You can just scroll through this, look at some Python code, learn it as you go through it, and then there's more stuff at the bottom to learn more about it. Encourage you to look at a tutorial for it, and we're going to look at the documentation pages for Python as well. One fun fact, I guess, is Python is not actually named. Its mascot is a snake, but it's not actually named after the snake. It was named after the Monty Python comedy group, if you guys have heard of them or watched their movies. So you're going to notice a lot of, if you go to the documentation pages, there's going to be some puns, okay, that you will enjoy. If you install Python on your own machine, for example, the default Python editor is called idle, and that's like a reference to one of the group members' names. So you can have fun with that if you know about that. So yeah, let's get started with Python. I will show you the Hello World program, of course. That's what I'm required to show you. And you're going to see very quickly why this is the first language that a lot of schools teach their students. So we had to make it difficult for you guys, but I think you're better off because of it. But here's what we're going to do. We're going to make a file called hello. It's not .java or .cpp. It's going to be .py for Python. And there's only going to be one line in it for a hello world program. It's just like the line that you want to run is a call to the Python print function that by default adds a new line at the end. And then we're just going to give the string. We're going to say hello world, whatever, blah, blah, and close it off. There are no semicolons in Python. That's going to be the one line. All right, let me show that to you. Hello.py. And so here, legitimately, here it is. Print hello, comma, space, world, exclamation point. Ta-da. That is your hello world program in Python. That's pretty nice. There's no main function really in Python. There's a way to like get a similar thing, but like for all intents and purposes, you just start writing code and that is your main function as far as Python is concerned. It will just run all the lines of your file. To run the program, there is no compilation in Python either. It's just like you give the program to the Python command. It's called Python 3 because we want that version of the language. We say Python 3, the name of the program, and it will just run it. There's no compilation, it just like goes through it. It's called an interpreted language because of that. You just give the name and it's like, all right, hello world. That's it. Isn't that fun? So let's see what I want to say here. Comments in Python are a little bit different to comments in C++ and Java. C++ and Java comments are exactly the same. In Python, single line comments are with a number sign like for makefiles. So this is a single line comment. Again, no semicolons. If you want a multi-line comment, you essentially give just a really long string. You triple quote a string with either three sets of 3 double quotes or sets of 3 single quotes. Does not matter as far as Python is concerned. This is a multi-line comment. You end it off there. So those are all comments. They do nothing. It's still just hello world. Okay, so that's the start, which is very interesting, right? Some new stuff, kind of simpler in a way. Yeah, let's talk about the differences. So you've already seen some. So first of all, Python is an interpreted language. Every time you give your program to Python, there's no compilation process. It's just like it's going through every character of the file one by one, figuring out what are you trying to do. So if it sees the number sign, it's like, all right, I'm just going to eat up characters until the end of this line, until I see a new line. And then here it's like, okay, I'm just going to eat up characters until I see the closing triple quotes. It's like it gets to this line, it sees print, it's like, okay, I need to print something. What am I printing? It finds the curly braces, and then like, oh, okay, so this string, it builds the string a character at a time. So it's got to read the entire character contents of the file every time you try to run the thing. And that is very slow. It's not machine code, it's not ones and zeros. It's an interpreted language, all right? It's at least 10 times slower than C++ or Java programs if you make the same program in Python because of that fact, okay? There are slight ways to make that a little bit faster, but like that's what Python is doing. It is like, all right, you make your program. It is legitimately looking at each individual character of that thing every time it's running it, which is very inefficient. It's like you make your comments, got to read each character. It's going to run that line, like read each individual character of that line just to notice that I don't need it. And then you do print plus you, print 2 plus 2 or something. It's like, all right, I got to run that. Let me just give the full thing. Print high. It's like it's going to run. It's going to look at each individual character, try to figure out what you need. It's very, very slow. Print 2 plus 2 calculates 4, makes high. It's like it's running each individual character slowly. Yes?
It's just kind of funny how just adding a bunch of comments to your code makes it slower.
Essentially, yeah. It's got to find the new line now. It really has to do that. There's efficient ways to look for text like that, but it's still slow. It still has to do that. You can imagine that when C++ or Java compiles your programs, your comments are gone, right? You're getting rid of those for sure. It's making machine code. That's useless stuff. But Python's like, all right, just gotta keep reading, I guess. So there's that. Do I want to make a new file for this extra stuff? Yeah, let's talk about that in a new file. More Python.py. Python likes lowercase and underscores. Java likes camel case, counter GUI, stuff like that. All caps, capitalization. Python likes lowercase and underscores for their spaces. There's that. Okay, the next thing that I want to say is there are types, but there aren't in Python. There are no types that need to be declared in Python. It'll just figure them out for whatever you need. It just figures them out. So here I am, I can be like, x equals 42. There's no int. Even though the type of x is an int, in Python they still call them ints. But like you just say x equals 42. It's like, all right, shove 42 into x. It's like, sure, that's fine with it. There's no real explicit nature of types in Python until you run into errors because of them. So here, print Python 3, more Python.py. So there it is, printing 42. All right, so it's doing as you would expect, but it's doing that. It does know that the type of x is 42. There's a function called type in Python that will calculate the type of the thing. It's like, all right, yeah, that thing was an int. Like it's happy, but types are weird in Python. Python is called a dynamically typed language. So it's just going to figure out the types for you, and with a mixture of that and the fact that it's interpreted, if you use the wrong types and eventually in some way, like your editor or Python, they're not going to complain. It's just going to try to run the program, and you're going to get a runtime error. So what used to be a compile time error is now getting shoved into a runtime error, every one of them, for the equivalent issue in C++. So all syntax errors essentially become runtime errors in Python because of that, which is interesting to think about. Yeah, so Python doesn't really care about types, though it knows about them. And so I am going to do something right now that's going to make you feel very uneasy. Watch. X equals a string. Python is fine with that. It's like, all right, X is a string now. It's happy. It does not care. All right. It's like, all right, print X, print the type of X now. All right, it's a string. It's called str in Python. Cannot do that in Java or C++. So it's just like, all right, it doesn't care about types. It's just like it lets you put anything anywhere, essentially, which is fun to think about. So there's that. Because of that, and because you don't really say types anywhere, instead of when you're making a function, there's no return type. So it's like, how do you know that you're making a function? You say def to just start defining it, even if it returns something. So here's how you make a function in Python. Let's see. You say def. I'll make a function that like adds 1 to a number. We'll call it add 1, and it's going to take a number, and we'll call that number y. And I'm just going to close the thing because, again, you don't say types anywhere. It's like, y could have been anything. Hopefully it's a number because that's what I'm going to do with it. Okay, I'm going to do number stuff with it. Okay, so I'm going to give it the body in just a second. The next thing I want to say is white space is very, very important in Python, which is honestly a good thing for first-time programmers to get used to like make the body of a function. There's no curly braces in Python. We're going to give a colon, and then we're going to tab over. And like the body of the function is everything that isn't indented. The indentation is key. It's part of the language, which is very nice. Just use white space. Otherwise, it's an error. So here's how you give the body of the add 1 function. You like give a colon, and then you tab over. Okay? So everything that is indented is the body of the function. Once you unindent, you're out of it again. So that's nice. It's really clean. It's forcing you to write clean code, one thing on a line. So that's pretty cool. I'll just return y plus 1, of course. Okay. So, all right, print, add 1 to 42. Let's do it. So there's 43. If I try to do that to like a string, this is a runtime error now. Like it does it. It runs most of the program, and then it gets to that line. It's like, all right, type error. It became that would have been caught. It wouldn't even compiled in C++, right? It's now a runtime error. Okay, so there's that. So white space matters. Instead of arrays, Python prefers what they call lists, which are essentially linked lists. So just think of the list type that I taught you in the containers lecture. So lists instead of arrays, but they function, honestly, they're kind of like vectors too. So just think of them like arrays maybe, or vectors. So lists instead of arrays, they call them lists. And here's the syntax for that. So it's L, like that's the name of the list I want to make, and then I just give it as square brackets. 1, 2, 3, or whatever. It's like there's my list, right? So the following is a list. So a list that holds 1, 2, 3 in it. Sure. Okay, so there's that. And you can go to a certain index of it, just like print L of 2 to print the 3. The syntax looks the same, even though they're called lists, and there it is printing the 3. Okay, so that's lists. They look a little bit different. Again, let me do something that's going to make you feel very uneasy. 1, 2, high. Python does not care. It's fine. You can have a list with some ints and some strings, some strs. It's totally okay with that. And then also, there's no concept of characters in Python. Everything's a string, just single link things. So strings in Python, therefore, you can use double quotes for your strings in Python, and I usually do that because I'm coming from C++. Or you can use single quotes for strings. There's no such thing as like a single length thing that's double quoted. It's like, I'm sorry, I could have said this. So that's the moral of the story. That's still the string high. Python doesn't care. Single quotes or double quotes. This, for example, that's still a string as far as Python is concerned. It's a string with one character in it. So there's no like separate character type in Python. They're all strings. At the end of the day, there's that. And yeah, let's do ifs. Ifs and conditions are pretty much the same. They're still if, else. The only change is that instead of else if, they decided to call it elif instead. They made it a little bit shorter, I guess. They're calling it elif. So let me show you that question first.
I've done Python before. Isn't there also just the default else if? It's like you can use a shortcut though.
Let's try. I honestly don't know. There's yeah. Let me check. That is a great point. I never tried. I just read it like that. So yeah, let's see. So grade. Let's do like a grade calculation program. So like here's a C. We'll be like if grade is greater than or equal to 90 or 90.0 or whatever, I will print A. That's an A. Let's see, how do I want to show you this? These parentheses that you normally give in C++, unnecessary. Or in Java. They're unnecessary in Python. It's just like the condition is everything before the colon. So there's the body of the if. And then elif is what they want you to use. Elif grade is greater than or equal to 70. Then it's a C. And then else. It's an F. So there's that, and it should work. So there's the C. If I do like 90 exactly, it should become an A. If I do like 55 or even 5, I guess, and it should be an F, and then I can change it back to 77. But yeah, let's see. I think yeah, it's a syntax error. That is not allowed. That is not allowed. It is elif for sure. Yeah, at least we know now. You can still do the old way of being like, all right, we can make this could have been part of the else, and then like you could have indented, like this could have been another inner if else. Like that's a thing, of course. Maybe that's what you thought. That's a thing still. Okay, yeah. In that case, no worries. But yeah, that's still possible. Of course, you can have nested things, of course, in every language. But this is like the standard way of doing things. It's if elif. As many elifs as you need instead of saying else if in Python. All right, I think that that's what I wanted to show for this file. Are there any questions about that? Any questions about these things? So there's that. When you make methods, and I'll do that in the next slide, you have to, you know how I said like secretly, there's always that this parameter that you're getting, like you always have access to that whenever you're calling a method. I made you do that in a lab, right? So every time, like in C++, whenever you said like c.inc, you made your counter, you called inc on it. Really, that's translating into a call to every method is secretly a function called counter : inc that you thought it took nothing, is actually taking the object, taking a pointer to that object, and that's how it knows to mess with that counter's count. So it's really C++, the compiler is translating it into this thing. It's calling it with that secret 0th parameter called this, all right? And so in Python, you have to explicitly talk about that this parameter when you're creating your methods. So like you actually have to give room for it. It'll be implicit when you call it though. So I'll show you that in a second. And in Python, it's not called this, they call it self. And so it's another throwback to that lab. So that's why I called it self back then. Okay, so there's that. And then the libraries are also next level. I'd say the Javas are on top, but there's still some very cool libraries in Python, and I'm going to show you one later. Okay, so let's do a counter class for Python now. And you better believe we're going to indent all the methods, right? So the class itself. Let's get that started here. How do I want to do this? I'll make a new file called counter.py. So here's how I want to use my counter class. I guess I'll say it like this. There's no types. I'm just like C equals my counter. I'm going to call its constructor. So there's a call to the constructor. And then you say c.inc, like the method calls look as normal. If we had it, we're just pretending we have it. Like print c.getCount, like that's a thing still. And then I think that's kind of what I wanted to show you there. So let's make that class now. It's called, you say class, counter, and then you give a colon. Of course, there's no braces. Then you tab over and everything inside of the class is indented. So that's important. Indentation is key. Yeah, you're gonna write self everywhere. When you call these methods, okay, when you call these methods, it's implicit. It's gonna get translated into, this line gets translated into a call to inc with the object right there as the secret 0th parameter. And we have to explicitly talk about that 0th parameter as we're implementing, right? So that's one thing. I'll show it to you. And then also the constructor's name is not the name of the class anymore in Python. It's called underscore init. Underscore. That's what they decided, right? So constructors in Python are called underscore init underscore. And so it's going to be def that underscore init underscore. And then it's going to have self as at least always the 0th argument. We're calling it self. All right, and then we give a body. So, all right, every method as you're implementing it explicitly takes the self, even though it's implicitly when you call it, it's going to do it for you. Explicitly when you're making it, you got to give self here. So every method, constructor is a method, right? Takes an explicit self. Explicit. Did I spell that right? Yeah. Self parameter first, but when you call it, it's automatically passed. So the burden is on the implementer. Automatically passed when you call a method. All right. So there's that, and also there's no declaration of member variables. You want to make a member variable? You make it inside of the constructor. So let's make a field called count, and the way you do is like, all right, self is a kind of, I think they call them references in Python too. It's a reference to my current object. It's not like, think of it like a pointer. Like I'm going to make it here. I'm going to say self.count. That's how I create the variable equals 0 or something. All right. So the member variable gets made on this line right here. So all fields get made in the constructor. So that's pretty cool. And so here's that line. That's where it's happening. So the member variable gets made right there. That's kind of cool. So that's the constructor, and then we need inc, right? Inc and get count for now. So okay, inc, def, inc takes self, right? Explicitly takes the self, even though it's going to be passed automatically when we call it. We explicitly talk about it as we're making it. And so, all right, we say, how do you increment the count? You'd be like self.count. You can't do plus in Python. That doesn't exist. The best you can do, the shortest you can do is plus equals. That still exists. So that's how you inc your count. You got to go through yourself to get there. That's the only way you can reference your member variable. So that's inc. And we'll do the same for get count. Get count is a method, takes yourself, and it returns my count inside of me, self.count. That's the only way to access your member variable. So that's explicitly all there, even though when you call it, it's implicitly passed. Okay, so that's that, and then this should hopefully then print 3, right? So that is an example of object-oriented programming in Python. There it goes, printing 3. You can have default parameters in Python. So let's do this. Let's make a constructor that by default, it can also take a count here, and we'll by default make it 0. So if you don't give it, it will be 0. So we'll just say self.count equals count, whatever the count was. So if we don't say anything, if we do it like we were doing, like this will automatically jump up here, get the default count. It's really, this is an argument that you put right here now. It's the second, the first thing becomes the second thing, essentially. So I'll show you that in a second. But like, all right, that's going to get 0 if you don't call it with anything. But if you do call it with something, be like, let's make a brand new counter. We'll call it C2. Now I'll call it with like 42 or something. C2.inc. Print C2.getCount. Should print what, 44? So that's going to jump up here now, and it's going to give a value to count. Like, you don't get the default if you actually pass something. So what was the first argument becomes the second parameter, because self is explicitly there now. And then here I am setting the count member variable to the count parameter. And so there's also no ambiguity, even though they're the same name, because the only way to get your member variables is going through self. So that prints 44 correctly, and that's why. So yeah, I think that's what I wanted to say about that. There's a counter class for us. Questions about that? Oh, thank you. I made a little typo. Thank you, I appreciate that. All right, any other questions? Yeah. I got rid of them. That was just like, I'm going to put something here in a second. ... To be determined. Yeah. That's not actually Python code. So, okay. Kind of what's happening, again, when you call something is in C++, right, when you make a call, you are getting, when you go to your method, there's always a this for you. Like, you have your current object available to you through a pointer, right? Like, here's your object with all your member variables. In C++, when you call a method, there's always something called this, which points to you. It holds the address of your current object every time you call a method. In Python, you got the same thing, but with self. Self it's called a reference, I think, in Python. And so it's just a way of getting at your current object. It's just like kind of like a Java reference. It's like you can use the dot still. It's not really a pointer. There's no dereferencing, even though you call it a reference. Okay? So you just like it's tied to your current object, and that's how you access all of your member variables. So I think that's what I wanted to show there. I hope that makes sense. All right, are we ready for a library? I'm going to show you a cool Python library. All right, so what I like to do is show you a library called the Turtle Library. It's so cute. It's wonderful. I teach it in my CSCI 1 class. It's super, super cool. So here's the documentation about the Turtle Library. And it lets you draw stuff, right? So it's very cool. You got a bunch of cool functions about drawing stuff. And so here's the metaphor. This is why it's called the Turtle Library. It's so sweet. So here's my artist rendition of a turtle. And here's his tail. And somehow, this virtual turtle got his tail dipped in ink, right? And he also understands English. It's a trained virtual turtle as well. So you can ask this turtle with his tail dipped in ink to move 100 units. By default, he's facing to the right. Like, turn left, Mr. Turtle, by 90 degrees, and also go forward 100 units. Like, you can tell him to do that. You can also tell him to pick his tail up, so you can move him somewhere and not make a mark. That's a thing. Or, like, keep picking the tail up and down to make, like, a dashed line or something. That's a thing, okay? So that's what we're going to do. We're going to command a virtual turtle to draw cool stuff. And I'll show you the extent that you can go with that. It's really, really cool, the kind of stuff that you can make. So, yeah, to use the turtle library, just like in Java, you're going to say import the turtle library, and then you get access to all the turtle library functions, all right? So here's all the names of these functions, like, hey turtle, go forward by a certain number of units, turn left by a certain amount of degrees or something. Here's an example of it. But when you call all these functions, you don't just say left, you say turtle.left. So this is like Python's version of namespaces. When you import this library, everything inside the library, you say turtle dot to get to it. Like, you're going to say turtle.move forward, turtle.forward, and call it like that. And this is supposed to be like a namespace where, like, maybe you have some other library that also has a forward function inside of it. Now you can differentiate. Like, it's turtle.forward versus the other library's .forward function. Like, that's that. There's a way to, like, use the namespace turtle, essentially. But I'm not going to show you that today. So that's for drawing stuff. Drawing stuff programmatically. And let's make a box or something. Just something simple. So turtle example.py. So I'm going to import the turtle library. And then for some weird quirk of history, the shape of the default turtle does not look like a turtle. And that is wrong. So there's a way to make the turtle look like a turtle. So it's the turtle.shape function. And you can give, as a string, what you want the turtle to look like. We're going to make him look like a turtle. So we're going to give the string turtle. You can make him look like a circle or a square, though, if you wanted to. So I'm going to say turtle.shape turtle as a string. And because it's a string in Python, it could have been single quotes as well. Does not care, as long as you're consistent. So there's that. And then after you're done making your pretty drawing, you say turtle.done to just keep the window on the screen and not close it yet. So this is like keep the window open. So yeah, let's run this program. There's a weird quirk of the way that Python works here. So there he is. Look at him, he's so small. And so he's ready to draw stuff for us. All right, so by default, your turtle starts, there's a coordinate system deep down in here. By default, the turtle starts at coordinates 0, 0, facing east or right. All right, so that's where he's going right now. That's his current location and direction. And let's just remember that. Oops. So the turtle starts out at 0, 0, facing east, with his tail down, and the default colors is black. Okay, so I'll show you how to change that in a second. So let's make a square by telling him, hey, Mr. Turtle, go forward, right, from where you are, go forward by 100 units. 100 units, and he's facing to the right, so we'll draw in that direction, right? Make a line right now. Hey, Mr. Turtle, please go forward, turtle.forward, by 100 units in this virtual land. And then, here, let me close it, rerun it. And you get to see him, like, if this was not, like, a bugged-out program, you get to see him actually draw the thing as well. But this is Linux inside of Windows, so it's a bit weird. But he did it. There he is. He's drawn it, and he's ready to go forward even more to the right now, but I want to draw a box. So I need to turn him. I want him, like, he's facing that way. I say, turtle, turn yourself to the left, right, by 90 degrees. That'll face him upwards. So there's a turtle.left to do that. Because right now he wants to move some more in this direction, but we want to say no. Move to the left, turn the left by 90, so that I can say go forward again by 100, and that will move you again that way. So that's what I'm going to do. I'll say turtle dot left 90 degrees, and then forward 100 again. Boop. And sadly, you're never going to get to see him draw, are you? So there's that. There he is. He drew the thing. It's wonderful. And yeah, that's more or less it. So like, let's close it off. We got to turn left again, Mr. Turtle. So right now he wants to go up some more. He wants to face this way. So we got to turn to the left 90 degrees again, go forward 100. And then the same thing, right? He wants to go that way some more, turn left by 90 degrees, go forward 100. And so we finish right here, and it'll be facing downwards. So yeah, if I showed you loops, this would be slightly easier, right? So like that. That's what we need. 4 forwards eventually. Ah, man, you can kind of see that he wants to draw, but there's a bug in this code. This Windows to Linux translation. So, oh well. But he drew the thing, and he's facing downwards. Cool. And by default, the line is black. So there's that. Let's, I don't know. You can change the color of this by changing it's called turtle.pen color. You just give a string that corresponds to a color. You can give RGB as well. But I'll say like turtle.pen color pink. Something like that. And just for fun, just so you can watch him draw, I'm going to call like there's an input function that just like gets input from the user. Before it draws, I'll ask it for input, and hopefully I can get the window working before then. So here, for you, there we go. So he hasn't drawn anything yet because I stopped it right there. Let's see what I can do. Here we go. And now if I press enter, you'll actually watch him draw. Look at him go. And so he's drawing a pink square this time. So like this is how it's supposed to work, really. So there's that. What else do I want to show you? So yeah, let's do a triangle. So he wants to go right here. Let's move him down to here so he can draw a triangle. So let's move him down pretty far, and then we can start like drawing a triangle like this. Boop, boop, boop. Okay. So like let's get him to here. He wants to move forward, so let's just let him move forward. wants to move downwards. So forward by like 200 or something. And then that'll be like, now you're in the position to draw the triangle. But there is going to be a slight problem right now. There it goes. There will be a slight problem because his tail is still down. He's drawn that line to get to the new spot to draw the triangle. His tail is still down, so he's drawn like a P. You can ask him to pick his tail up. Is the moral of this story. You can be like, hey, turtle dot up. It's somewhere over here. There. It's either, you have many options. There's a bunch of synonyms. You'd be like, hey, turtle, pen up, PU, or just turtle dot up. I'll use that one. So we want him to pick his tail up as he's moving. Turtle dot up. Get to the right spot. It's like, pick your tail up, please. And then go forward 200. And now he won't make a mark as he's moving down there. Come in. So now he's there, and he didn't make a mark as he got there. Okay, sorry it's so small. But now we can draw a triangle. So let's see. We want to put his tail back down now. Now that we're ready to make marks again. Turtle dot down. And let's draw this new triangle with a different color. It'll be like pen color. Instead of pink, let's make it blue or something. I don't know. Blue. So now he's going to draw blue marks now that his tail is down again. And so, okay, he's facing downwards right now. If I want to draw the lowest part of, let's make like an equilateral triangle. If I want to draw this part, he is facing this way, and we need to turn him. That's to the left still, right? Left 90 to get facing this way again, to go forward. So we need to tell him to turn left 90, and then we can go forward again by a certain amount. All right, so turtle dot left 90, and then we can go forward some more. Let's do 100 again, 100 length. So close this. We'll rerun it. It is fun to watch it work though. Here, let's add back in that input thing. I'm sorry that's necessary, but whatever. Boop. And so here I'm going to press I'm going to get it set up. Then I'll press enter and you'll watch it work. And there he drew the bottom part of the triangle. Perfect. And so, all right, now the goal is we want to draw this exact triangle, right? So you thought you never needed geometry ever again. Now you do. All right, so the turtle wants to move this way. We got to turn him, right? We got to turn him by a certain amount. What are the degrees for each angle in an equilateral triangle? Very good. So these are all 60s, and that's going to be very important. And so you might be like, all right, I need to turn left by 60 degrees. That actually won't work. Think about why. So I'll be like, all right, I need to turn left by 60. It's like that's the interior angle of that triangle, right? Then I'll go forward 100 again. But there will be a slight issue there. Again, fix the window. There it goes. Getting good at this. And enter. That was not enough. He went and flew off that way. I forget what this is called, but this angle, this is the angle that we want to turn him left by. That's bigger than 60, right? It adds up to 180. Is that called a supplementary angle or a complementary angle? I can't remember. Well, that too. But because they add up to 180, there's this special name. Is it complementary? Or supplementary? Yeah, I don't remember. So one of those words. But that's what we need. We want to go forward, or we want to turn left by that amount, which is 180 minus 60, all right? Which is 120. That's how much we want to turn left by. It's really a 120 here, and that will do it right for us. But we don't even have to do the math, right? This is Python. This is a programming language. I'm like, go turn left by 180 minus 60, please. Figure that out for me, Python. That's the beauty of it, all right? And then it should work. Let me So it was supplementary then? Thank you for your fact checking. So I really don't remember. Okay, and so now we want to do the same thing, right, for that last line. It's like we wanted to zoom off this way, and for the same reason, it's not a left turn by 60, it's a left turn by 120. All right, so we want to do that again, and that'll get us in the right spot to draw our last line. I'll move us that way, right? Our last thing of the same. It's an equilateral triangle. So again, 4 to 100 though. So boop, just like that, and that should do it. So is that everything? That should be everything. Watch it work. There it goes. So beautiful. We did it. So yeah, I think that's what I wanted to show you. That's the turtle library. Make little pretty pictures like that. Any questions about that? It's a fun little library. What do you mean import in the terminal?
Well, I mean, I've seen an error that says
It could be because the class server doesn't have a screen. I might have, like, you might have to, like, you might have to install that in a different way. But I'll come and look at it after class. Okay, just ask me about it. I think it's because the server doesn't have a screen. It didn't install. Maybe it didn't install the turtle library. Alternatively, actually, one other problem that you might have is never name your Python file the same name as a library you are using. That might have been what you did. Did you call it turtle.py? That's the problem, because when you import a library, it's really going to look for a file called turtle.py somewhere. And if you call your actual program that uses the library also turtle.py, you've now lost access to the original library because that's going to take precedence. That's a problem. All right, so there's also a math library, so never name a program that uses the math library math.py, because then you've lost wherever the math library really was. So that's another problem that you might run into one day. So thank you for that question. That's very helpful. I forgot to say that. All right. I have a couple more examples for the day. Let me show you this first, and I'll show you the cool examples. So Python, if you just run Python 3 by itself, it plops you into what's called the REPL. I'm going to say Python 3. It plops you into what's called the REPL, which stands for, it's an acronym, Read, Evaluate, Print, Loop. Read, Evaluate, Print, Loop. So it's going to read your text. You hit enter, it evaluates it to 4 or whatever, and then it'll print the answer, and then it loops again. So you can give single lines of Python code one at a time here, just to do quick math or something. Like, what's 2 to the 100th power? It'll calculate that. Python is really cool in that, it has arbitrary precision integers even, and so this is way bigger than 32-bit land. It just does it for you though. It has big integers, we say, which is nice. And so it's just useful for all right, x equals 42 over 5, what's x squared or something. To do quick math, the REPL is useful for that kind of stuff. To get out of it, you say Control-D or quit, called the quit function. There's that. So that's the REPL. I use it a lot just for math. And yeah, the last things that I want to show you is how far you can go with the turtle library. So let's see. Is that the only example that I have? Is there a question first? Say that louder, please. The REPL just it plops you into Python. You can run individual lines of Python code. It's not hooked into any files or anything. It's you can run a line of Python code, and it will run it to completion and print out the answer. It reads, evaluates, and prints. Yeah. And so you never have to actually call print either. There's no such thing as print 2 plus 2 in the REPL. It's just it will compute the answer and print it for you. So it's very useful like that. Yeah. All right. I think, the last thing I want to show you is just one cool example of how far you can go with the turtle library. So let's see. I've made this program called joydivision.py for a reason. I don't know if you guys have seen the hipsters with the Joy Division album cover shirt, but here's an example of it. It was here, this album cover. It's very small, but on Wikipedia at least. But you've probably seen this on somebody's shirt before. It's just a fun little cute image, and where it comes from, that picture that was on the album cover, comes from the the oscillation signal from a certain celestial object called a pulsar. I think that's how you pronounce it. This specific pulsar, like you gotta shoot an antenna at that exact one, and you can get some, like it outputs radio waves, and you can read the intensity of those radio waves. It pulses essentially with that period, and somebody back in the 70s took some readings from that pulsar, and here are a bunch of different pulses from it for like a few minutes. Like each pulse is like a minute long, and like there are a bunch of oscillations of it, and so like it's just a bunch of numbers. Like the signal was this amount, then it got a little weaker, even more weak, and then it got more strong. Like it's going down and up and down and up, and you can plot that with the turtle library. You can plot those signals oscillating, and so here's that example. And if I can resize the window, of course. And then you can ask the turtle to draw that pretty picture, which is cute. So I cannot dream of teaching you exactly how I implemented this, but like here's the signal. It's a list of lists. Each oscillation is like this amount, and like we're just plotting it. It's like telling the turtle like to move, like if from negative 81 and negative 91 it went down, right? So like tell the turtle to move down and to the side, then go up, right? So go down into the side some more, go up into the side, go up into the side some more, down into the side. Just like keep on plotting, right? And eventually you can, like if you do it the same way they did it, and like you overwrite, it's like overwriting the previous lines to make it look pretty, I guess. You can see the images. It's really cute. So I made a bunch of little helper functions, but it's the turtle library that's doing the heavy lifting. So here I am, import turtle, and then random for some reason. But I'm doing some fun stuff. I got to draw a rectangle function, draw a polygon function, draw a line, and then each oscillation is like a fuzzy line going up and down. So I made a function called draw fuzzy line for that. And then it's just, I'm iterating through with a for loop, all of that number data, and drawing a bunch of fuzzy lines on top of each other and asking the turtle to do it nicely. And at the very end, you get the album cover, which is really nice. And then just for a nice touch, you get the turtle at the bottom right too, if you choose to not hide him. So that's one of that's the extent that you could go with the turtle library. Even you can draw cool stuff for sure. It's all possible one way or another. So I think that's the last cool example that I wanted to show you for the day. So feel free to look into that, and I can explain it more offline. But I think that's the last thing I wanted to show you for Python. And yeah, I'm not going to test you on any of this, but you need to know it because, like, depending on where you transfer to, all the students there have probably seen Python, potentially. So you're welcome. And I think that's all that I wanted to say about Java and Python. Are there any questions about any of that before I talk about your last lab? I think that's the last thing I need to talk about today. Please do attendance. I think I have not yet stopped that, so if you've forgotten to do attendance, I will stop that after I explain the lab. You have been warned. Here's your very last lab, due next week, December 6th. Let's do it. So, here's the write-up. Then I'll go to the code as well. This one is about bitwise operations. Code 40, what was it? 11. Here are all the files, and let me show you what you're doing. So there's like a bitwise operations library that you're going to make. So just like every function in the header file, you will be implementing. So here's the header file, bitops.h. So here are the functions that you're going to be doing. It's like, all right, is bit set, and by set and unset, I mean when a bit is set, it means it's a 1. When it's unset, it means it's a 0, okay? So is bit set takes a number and takes a bit number inside of that, and it checks if bit I of the number n was set to a 1 and returns true if it was, false if it wasn't, all right? So remember the order of the bits. We start at 0, okay? So let's see, do I want to write that somewhere? Bit 0 is the rightmost bit of a number. The very last bit, that's bit 0. So like if this number is 7, bit 7 is set. Or sorry, excuse me. This is the number 7 in binary. Bit 0 is set, bit 1 is set, and bit 2 is set. And this is bit 3. Sorry, 0, 1, 2, yeah. Bit 3 is unset, and everything after is also unset. Okay, all the way to 31. So it's 32 bits total. Yeah, we got 32 bits total. I'm going to use unsigned int so that you don't have to worry about negativity or anything like that. But so that means we have 32 bits to talk about and access bits 0 through 31. Okay, that's what we get. So that's what is bit set is going to check. Takes a number, takes a bit number. It's like, is bit I of the number n set? Right. So go back and remember which bitwise operation you need to use and what kind of comparison you need to make there to check if a bit is set to a 1. So remember the ordering, the number of bits. All right. There's that one. There's count bits. So this takes a number and it counts all the bits that are set to 1 in that number. There's 32 of them, remember? Do you see how you might be able to use this function to implement this function? Make your life easy. So there's that. And then finally, set bit. Takes a number by reference and a bit number, and it sets that bit number I of the number n, to a 1. Make sure it's a 1 even if it wasn't already. Right? Keeps it a 1 if it already was 1. So that's set bit. All right? So yeah, count bits should count the number of bits that are set in a number. So like the number 7 in binary is this, a bunch of zeros and 3 ones at the end. So count bits on the number 7 should return back 3, because there are 3 bits set in the number 7 in binary, right? And then sets bit I to a 1, all right? So there's that. And so yeah, you're just going to implement all those in the CPP file. I've got stubs in there right now. Every bit is set. There are negative 42 bits in every number. So like implement them correctly. For this one, you can use this one. And yeah, remember this one's going to work by reference. So you're messing with n itself, okay? So those are those 3 functions. Are there any questions about those? Kind of see how you're going to implement them. Let's go to you first.
So we're setting, so we're only using the positive numbers, we don't have to worry about negative numbers?
Yeah, that doesn't really matter if you're doing bitwise stuff anyway, but just to make it easier, you don't have to worry about just the idea of negativity. Like these are unsigned int, so they can never be negative. Yeah. Other question? Yes, we said that a bit is set if it's like it's turned on, the light switch is up, it's a 1. Yeah. High voltage. So, yeah, I got some tests for you. I got a make file that compiles it. I mean, you just say make, right? Make by itself will run the first rule. It's called test bit ops, which is the name of the executable. It's beautiful. You're welcome. And then here's that file. So I've made a few tests for you already. There they all are. And like checking a bunch of bit sets. So 15, remember, in binary is 1, 1, 1, 1. So bit 0, 1, 2, and 3 of 15 are set, but every bit after that is not set. That should give back false, right? And then I'm just doing other things. Let's see. Though I am using unsigned ints, I'm still using -1. Maybe I should have said tilde0, but remember that -1 is just the number with every single bit set. This is an easy way to get at that. It's going to be translated into an unsigned int, though. It's just a really big positive number. So that's what I'm doing. It's like every bit is set. That's just an easy way for me to do that. And then I got a bunch of combined tests. All right. So like apparently if you start with 42 and you set these particular bits, you end up with this big unsigned int. Okay. So those are those tests. Get those to pass. And then your job is to write 2 more in this style. Right. So I want to see passed 2 extra times in your program after you get mine to work. So compile like this. Either just say make or make test bit ops. Run it, get mine to pass, then you write 2 more tests, like come up with some wild combination of those 3 functions. Run them in some weird ways, test them, make sure they all work. And I think that should do it. Am I going to force you to do anything else? It looks like, yeah, my tests are not checking for like invalid bit numbers right now. So you can handle that as you would like. You can throw an exception if you want. Maybe that's a new thing you could add and test for. But I don't think I'm checking for invalid bit numbers. Like go and set bit -1. Go and set bit 55. Those don't exist, right? But yeah, I'm pretty sure, yeah. So I'm not checking those. That could be a test. There you go. You got an extra one now. So yeah, I'd get 2 more to pass. And I think that's it. So yeah, the 2 files that you'll turn in are your implementation of the bitwise operations in the library file. That's this one, sorry. This one, as well as your 2 extra tests in the test file. Okay, so that's what I want you to turn in, and I think that is everything. Yeah, so that's going to be your last lab of the class. Any questions about it? All right. right, so I think that is officially everything. So the rest of the time is all yours to work on it.